Hey guys, BuildZoid here, and today we're going to be addressing something that I keep seeing in comments, which is the fact that you do not need to disable CEP in order to undervolt. I've technically already covered this in a previous video, but as is so often the case with my videos, people don't understand them. So we're doing this again. I'm gonna show you what happens when you undervolt the wrong way and trigger CEP, and then how to undervolt the correct way, which I've already shown in a previous video. I just didn't show the whole, what happens if you do it wrong. So, anyway, here we are with the Gigabyte Z790 Aorus Master X on the F7 FBIOS with a 14900K, so we're on the 129 microcode, which imposes the 1.55 volt core voltage limit, vid limit, which translates into a 1.54 volt core voltage limit. Yeah, we're gonna take a look at this here. So if we go into the advanced mode with F2, you'll see that Intel default settings is set to extreme. And if we go to advanced CPU settings and check the CEP setting, right now this is actually incorrect because the tooltip says auto is set to disabled, except the Intel default settings profile actually overrides the auto setting for CEP as well as a whole bunch of other things. So while Intel default settings is turned on, CEP by default is turned on, and I don't think you can even disable it. I think even if you do this, the Intel default settings still override that. So, yeah, anyway, we'll just leave this on auto. Now, that's all we're going to start with. And so the first things first is CEP monitors that basically the difference between the voltage that the CPU expects based on the load line and the vid request against the voltage that it actually receives. And if the difference between the expected voltage and the actual voltage is too big, CEP triggers and downclocks the CPU. So if you start undervolting by setting a voltage offset at the voltage regulator, the CPU isn't aware that there's there's an offset applied to the voltage. So it sees that, hey, the voltage is 100 millivolts below where it's supposed to be. Therefore, I'm probably pulling way too much current, and it starts downclocking, which creates the performance drop. Now, CEP stands for current excursion protection, so I wouldn't really recommend turning it off, at least if care about the longevity of your CPU. Now, this might not actually be necessary, but I don't know for sure exactly what causes 13th gen and 14th gen CPUs to degrade. And so because of that, in my suspicion is that basically all of the degradation is due to Intel's stupid VDROOP compensation. And it's not anything to do with power limits or current limits or anything like that. It's just the fact that the CPU sometimes sends vid requests for 1.6 volts, and then it gets 1.6 volts. Seems like a kind of dumb thing to do, but anyway, yeah, I don't know that for sure. And so if you want to be safe, you probably shouldn't be turning off something called current excursion protection, because the Intel documentation doesn't actually explain what CEP is supposed to prevent. Right? It does say something vague about oh, it's supposed to prevent excessive current, but it doesn't say what the consequences of excessive current are. It's probably degradation, but how much of it? I don't know. It doesn't say. How So I wouldn't recommend turning off CEP if you want your CPU to last a long time. So, yeah, and at this point, a lot of people might be like, but you can't undervolt without CEP, and that's just not true. You can undervolt, you just can't do things like use the dynamic vCore here and set a minus 130 millivolt offset, which we're not going to do here to start with. I want to show you how the 14900K is supposed to perform with the Intel default settings, and then we're going to do all the things that trigger CEP, and then do all the things that don't trigger CEP, that do work for undervolting. But yeah, the main issue is that if you have CEP turned on, you can't lie to the CPU about what voltage you're going to give it. Okay? You can't do that, because if you're lying to the CPU about what voltage it's going to get, it's going to trigger CEP, because the CPU basically sees that the voltage is too low, and it thinks it's pulling too much current. And the reason Intel implemented this way is because, in theory, this is way faster than like waiting for current monitoring data from the voltage regulator. The funny thing is they also have the ICC max current limiter, which is like another current limiting mechanism that is like separate from CEP as far as I can tell. But you know, like, um, yeah, so like Intel has a whole bunch of safety features. Actually, they have like a whole bunch of features built into these CPUs that I'm not entirely certain that they internally know what they even are. Or like the person who, like, it really feels like certain things about this platform was like one team implemented something and nobody else heard about it. Um, which would explain a lot of the issues. So for cooling, I'm just using a 240 millimeter AIO here. It's not super warm in the room. It's about, I don't know, like 24, 25 degrees Celsius. Um, and this is like a short test. So obviously if we ran it for longer, as the temperature builds up, the, score would come down. But basically, if your CPU isn't, like if you have a 14900K and it's not thermal, like, and you have like actually, it really shouldn't be thermal throttling on the Intel default profile unless your cooler is terrible, because the Intel default profile has a 253 watt power limit, which is not a very high power limit. But anyway, you should get something in the neighborhood of like 37,500 points. Actually, chances are your CPU is probably better than mine, because mine is absolutely horrendous. The all-core vid on my CPU is like, the maximum all-core vid on my CPU is like 1.4 volts or something. This chip normally runs Cinebench at around 5.2 gigahertz. I have heard of like 14900Ks that out of the box, even with like sensible power limits, will still manage to do like 5.7 all core Cinebench. This is not one of them. um, anyway, so 37,500 points. And now, if we undervolt the CPU incorrectly, we're going to see a CPU that's like below 30,000 points. Man, why is this system so freaking slow? Anyway, so yeah, now we're gonna like undervolt the wrong way. So do not, like, if you're undervolting, don't do this, because you're gonna trigger CEP. So yeah, we just use dynamic vCore here to set minus 0.135 volts. And now the problem with doing this is that voltage offset is applied at the voltage regulator. So the CPU sends a vid request, the voltage regulator receives the vid request, and then applies vdroop to it, and then offsets the voltage down by 135 millivolts. So the CPU doesn't know that there's this minus 135 millivolt offset. So then the CPU gets this really low voltage, and CEP sees that really low voltage and goes like, wait a minute, that's not what I asked for, and starts clock stretching, right? So your performance falls off a cliff. Um, and Yeah, and there is a way to do undervolts, even like 135 millivolts, like what I just did, that won't trigger CEP, which, I've shown in a previous video, but I still see so many comments from people complaining about how CEP is ruining their undervolts that evidently they didn't watch that video, or they didn't understand it, or both. Um, um, Actually, you can't do both. Like, if you watched it and you didn't understand it, that's one. And if you didn't watch it, well, then you didn't have the opportunity to not understand it. So anyway, but yeah. So right now we're gonna have just horrendous performance. And then the other thing is like a lot of people like to set their AC load line below the actual load line of the voltage regulator, which causes the exact same problem because you're lying to the CPU about what voltage it's going to get, right? So if you tell the CPU that there's no V droop and then your motherboard has a bunch of V droop, CEP gets very upset because CEP was expecting to get, the vid request without any V droop, and then the voltage is like 100 millivolts lower or whatever. And yeah, that causes like the CPU to start clock stretching because the CPU thinks that it's pulling like way too much current. Um, so anyway, this should put out something around like 20,000 points, I think. Maybe more than that. Okay, no, we got about 25,000 points, which is horrendous, right? So yeah, you don't, if you have a gigabyte motherboard and you're using the Intel default settings, you do not undervolt by using the VRM voltage offset. Now, if I had my way, I would actually label that setting as like VRM voltage offset and then the vid offset as like vid offset. I don't think that would necessarily clean up the confusion around like this behavior because I think most people don't know what a vid is or what a VRM is. So the fact that you'd have like two different offset settings wouldn't really help, but at least it would be clearer slightly. Anyway, so we're going to set that to auto, and now I'm going to do the other thing that makes CEP really upset. I'm going to set the AC load line way below the actual load line of the motherboard. So we're going to set our AC load line to, I don't know, 40, which is like what Gigabyte likes to set the 14900K2 out of the box, which would normally, like with CEP disabled, this would actually crash in some workloads, not necessarily Cinebench R23, but with my CPU, 0.4 AC load line on this motherboard with CEP disabled. I mean, if you turn the power limits on, it probably won't crash, but without the power limits turned on, like the default Gigabyte settings, yeah, it would crash. So, yeah, but with CEP turned on, this won't crash. It'll just cause a massive performance reduction. Now, the funny thing about doing the undervolting this way is that you get less undervolting at high frequencies than at low frequencies. Or more like you get less undervolting at low power draw and more undervolting at high power draw, which from if my theory about the degradation primarily being caused by excessive voltages is correct, and those excessive voltages are primarily tied to low load scenarios, using the AC load line to undervolt your CPU is a terrible way of doing it because you're only undervolting all core load. Like your single core load is going to still run very high voltages. Your dual core load is still going to be running very high voltages. Now, it's going to be slightly less ridiculously high than it usually would be because of also the weirdness of how Intel's V-droop compensation works. But like if your priority is to get your like single core voltages as low as possible, the AC load line is the worst way of trying to do that because it just doesn't do that. It's just, yeah. Like if your priority is to get your like single core and low core, like low current voltages down, you want to use vid offsets. And the cool thing with actually 14th gen is like Intel actually gives you the ability to adjust the vid offset for every single frequency point. Now, personally, I wouldn't bother with doing that because that'll take forever to tune correctly. But you do have the option to just sit there and like adjust your 6 gigahertz vid separate from your 5.7 gigahertz vid, separate from your 5.5 gigahertz vid, from your 5.3. Now, obviously, the problem with adjusting each of your individual vids, like each, adjusting having a different offset for each of your frequencies is that stability testing is going to get very complicated because now you need to figure out how to like hit the CPU hard enough that it stays on that frequency that you're trying to, stress test, but not so hard that it downclocks because of like hitting the power limit or the thermal limit or whatever. That's the main reason I'm not a big fan of like dynamic tuning is like you don't have a good way of like, verifying the stability across a large range of different frequencies, because it's really hard to keep the CPU, like, you might find a test that's like, oh, yeah, this holds 5.7 gigahertz on all cores. And then in the real world, you might actually end up running an application that also manages to run 5.7 gigahertz all core, but it's slightly heavier than the thing you were stress testing with, so now your system locks up, right? Anyway, so you can see that, yeah, by adjusting the AC load line, I've made the performance drop even worse, right? Like this is just a disaster at this point from a performance perspective. So now let's take a look at how not to do that. Now, also, I would actually suggest that you do adjust the AC load line a bit, because it's not inherently, like, the thing is, if you're adjusting the AC load line, you would also want to adjust your VRM load line. And if you have an Asus motherboard, you actually might have the option to have the VRM load line synchronized to the AC load line automatically. Actually, it goes backwards. I think you like set your VRM load line and then the AC load line setting gets synchronized to that. But anyway, if you're on other motherboards, you're basically going to have to like figure out. And the way I would actually do this is I would set your load line first and then manually adjust the AC load line down until you start seeing like major performance drops. But with with this motherboard, because other Gigabyte motherboards, so with Gigabyte motherboards using the Renesas VRM controller, because I'm assuming they all have the same load line programmed into the controller. I don't know if that's actually true, but it probably is, because generally motherboard, like at least Gigabyte doesn't usually give different LLC settings to the same voltage controller across their lineup. But there are a bunch of other Gigabyte motherboards, like say the Z790 Elite, that uses a on-semiconductor controller. I think it uses a different load line slope. I haven't yet verified. I am actually considering the idea of making like videos specific for each motherboard. But with this motherboard, the default load line setting is 1.1 milliohm for the VRM. And high is a 0.5 factor for like 0.5 multiplier for that load line setting. For if we use high load line calibration, then like 55 AC load line, this won't trigger CEP because we're telling the CPU, hey, there's 0.55 milliohms of E-droop, and then the motherboard applies 0.5 milliohms of E-droop, and everything is, like, everybody's happy because the voltage the CPU is getting matches the voltage the CPU is expecting. Now, you might want to push the AC load line as low as possible, which you can do if you set Ultra Extreme LLC. Now, the one concern I have with using Ultra Extreme LLC and then setting your AC DC load lines like this is that I am not 100% certain that the control loop of the voltage regulator is necessarily going to be stable on every motherboard if you do this. There are, the thing is, like, technically it is possible to tune voltage controllers to work with extremely flat load lines, but I don't know if every motherboard is configured for that correctly out of the box, and I have encountered motherboards that aren't. Admittedly on AM5, not AM4, and using not LGA 1700, and using a monolithic power systems controller, not a Renesas, but like, just in case, I would generally recommend that you just don't take the chance of like, hey, maybe the VRM isn't properly set up for zero V-droop operation. Anyway, so if you want to get the AC load line as low as possible, something like Extreme is basically as high as I would go. And Extreme should be 12.5% or maybe 15%, something like that. And so for this to work, you should be setting a load line somewhere around like 15 or to 20. Right? Like, you might have to like fine tune this a little bit. Basically, if your AC load line is too low, it's going to cause CEP, like it's going to trigger CEP, right? So like you can test for this yourself, is like you can set your, because I'm not 100% certain that this is truly consistent across all motherboards. But you can just like leave CEP turned on and then just adjust the AC load line up, right? You could start with 1 and CEP is going to be very upset. And then you can just go in increments of like say 5 or something until CEP is happy and stops ruining your performance. In order to like really dial in the AC load line. And then once you're done with that, you can just set the DC load line equal to the AC load line and you should be basically good in terms of your load line settings. So anyway, I'm just going to start with like 17 here with Extreme. Now, even with Extreme load line, this does cause noticeable overshoot on an oscilloscope. However, If your average voltage is significantly lower, that overshoot is also lower. And also, if you have a gigabyte motherboard, you do have the option to set a voltage limit right here, right, VR voltage limit. So if you like don't trust the voltage limit that Intel has in the BIOS of 1.55 volts, you can just set it to like 1400. And then that'll set a 1.4 volt voltage limit. Now, the overshoot is going to exceed that because that happens at the VRM. That doesn't happen at the CPU. Like, this blocks the CPU from sending vid requests above 1.4 volts. It doesn't prevent the voltage regulator from going above 1.4 volts. Right? Especially because the overshoot is actually out of the, like, that's outside of the control of the voltage regulator. Like, the reason you get that overshoot is because the voltage controller literally cannot react quickly enough to the transient, to the load transient that it's going through. So when the CPU goes from, like, very high load to low load, the current ramp, or, well, the change in like impedance of the CPU is so fast that the voltage regulator doesn't have time to react. So the voltage jumps up above the target voltage, which, if your target voltage is basically the same as the VR voltage limit, then yeah, that overshoot is going to go above that VR voltage limit, right? Like, if we send a vid request for 1.4 volts, we have 0 V droop or close to 0 V droop with Extreme LLC. So we're going to be sitting at, like, I don't know, like 1.38 volts or something. And then we get overshoot that'll go like 50 millivolts. We'll end up at like 1.43 peak. That peak is going to be very, very short though, and still way lower than Intel's like 1.55 volt, 1.55 volt vid limit. So it's still safer than like what the OX129 microcode does, in a way. So that's something to sort of keep in mind. Now, if you just don't want to have noticeable amounts of overshoot, I would recommend just sticking to load line settings below high. So like low, medium, high. You could also just not adjust the load line. That's also completely fine. It's just that adjusting the load line does slightly reduce the like starting point for the vid requests, just because of how Intel's like AC load line thing works. So you kind of want to so you'll get like slightly more boost basically, with a reduced load line out of the box. So anyway, am I actually going to set that VR limit? No, not right now. But I would, like, if you're really, if you really care about the longevity of your CPU and you have a gigabyte motherboard and you have the VR voltage limit setting, just set it to like whatever whatever you feel comfortable with, right? I think 1.4 is probably on the side of like unnecessarily low, considering that Intel is like extending the warranties and setting the vid limit at 1.55. So, but then again, Intel could be incorrect about how safe 1.55 volts is. So, anyway, yeah, so we're just gonna set this right now. So, right, we have like extreme load line, like VRM set to extreme, AC load line set to 17, and this is gonna like not trigger CEP at all. However, this isn't going to be a very substantial undervolt, so we're probably still only going to see like 37,800 points. Like, I don't think this is going to make a big performance difference. It is going to help a little bit because when you have the original AC load line on this motherboard is like 90, right? So we're going to have slightly less voltage when running Cinebench, but it's not going to be as substantial as like say a minus 100 millivolt vid offset. And quite frankly, like, I would just recommend that people don't touch the load line settings. For like, if you don't, if it doesn't make sense to you, just don't touch them. Maybe set a voltage limit and then just use the vid offset. Just don't touch the load line settings. Okay, like, that's probably for the best. Ideally, Intel would have like made it. Intel and the motherboard vendors would have like set the load lines correctly at the factory, but that's really difficult. So, nobody bothered to do that. Actually, considering how CEP works, I'm not sure why Intel didn't just recommend that everybody uses an AC load line of like 0.3 or something with a VRM load line of like 0.3, because as far as I can tell from a stability perspective, it shouldn't cause any issues, but I might be wrong about that. So yeah, that didn't really like boost the score very much because the thing is like when you have the AC load line properly matched to the motherboard load line, like it is technically going to send a slightly lower vid request, so you do get slightly more like power and like thermal headroom, but it's not going to be the same as just like setting a minus 100 millivolt vid offset. Like it just isn't. Like we might have shaved off like 20 millivolts. It does, funnily enough, significantly reduce the peak voltages because the way the V-droop compensation works is that it just slaps the maximum theoretical current that the CPU can pull multiplied by the AC load line onto a vid request. So if you do this where you like set the AC load line really low, your peak vid requests are going to get a lot lower, but your full load performance is not really going to change too much. That even then, like when you set like if we go here and we set the vCore voltage mode to adaptive, if we just set a internal vCore offset of minus 100, like that just takes 100 millivolts off the vid request across the board. So previously in situations where the CPU might have requested 1.55 volts, well now it requests 1.45 volts, right? And in situations where it would have requested 1.3, it now requests 1.2. And where it would have requested 1.2, it requests 1.1. And this isn't going to trigger CEP, so now we're going to see a pretty substantial performance uplift. And that's also why I'm saying, like, you don't actually have to mess with the AC load line at all, because even at idle, just adjusting your offset is going to lower the idle vid requests and the low load vid requests and the load transition vid requests. Like, all your vid requests are literally just getting lowered by 100 millivolts. So things that were previously above 1.5 volts are now below 1.5 volts. Now, admittedly, it might be possible that your CPU doesn't have much undervolting headroom and you can't, set a minus 100 millivolt offset without it like crashing constantly. I don't bin CPUs, so my sample size is literally whatever Intel sent me. And yeah, this CPU seems to have quite a lot of undervolting headroom. Also, you're going to have to stress test your undervolt, right? Like if you set your undervolt too low, the CEP isn't going to save you in this situation, right? Because you're literally like, if the CPU sends a vid request that's too low to maintain stability, CEP isn't going to get upset that, hey, the vid request is too low to maintain stability. That's not CEP's job, right? CEP's job is to make sure that the voltage that the CPU is receiving is like matching the vid request. So if the vid request is too low, then the CPU will just crash, okay? So anyway, but now I think we should see about 39,000 points. Why is it taking so long? And this OS is... I'm going to blame the OS for this. Oh, come on, just launch already. I guess it's not impossible that, like, my undervolts is too low. Oh, wait, no, it did start. Well, that's fun. Or it's something to do with, like, the LLC being too aggressive right now. Like, that's technically not impossible, because, again, like, CEP, if... Like, CEP should handle, like, excessive undershoot. But the thing is, this is, like, super hard to test for, and also this OS doesn't work properly even on, like, stock settings, so... Right, like, right at the start of the video, it was being incredibly slow as well, so, like, I don't know, this OS is probably just messed up at this point. But... Yeah, so now we're getting like 39,000 points, right? Like 39,500 points. CEP's turned on. Intel default settings are turned on. Like, you can totally undervolt with CEP turned on. You don't need to turn it off. You just need to figure out where your motherboard hid the vid offset. Yeah, unfortunately, the way the things in the BIOS are labeled is not very helpful a lot of the time. And the naming conventions aren't even consistent across the different motherboard manufacturers. Like, I think technically all, like, MSI, Gigabyte, and Asus all have, like, an override vCore mode, but it does different things on every single one of them, if I remember correctly. Or at least Gigabyte's override vCore is very different from what, like, Asus override vCore is. The equivalent of Asus override is, like, Gigabyte fixed mode. But anyway, so if we're on adaptive, you can just set a minus 100 millivolt offset, and that'll just offset all of your vid points by 100 millivolts. All right, and I'm just going to put this back up to high, and then 55, because I do actually think that's probably the better way of doing things, is like, not, like I showed, lowering the AC load line a bunch doesn't actually change the performance that much. So yeah, like, you're really much better off just adjusting the vid offset. And actually, you know what? Let's see what this does to performance right now, because I think this might actually even, like, if there was a lot of like transient response related clock stretching due to CEP with the previous setup, well, this might actually be slightly faster right now. It might be slightly slower. Yeah, I'm gonna go with this OS is just bad. Like, to be fair, my Windows installs get, like, dragged from motherboard to motherboard and CPU to CPU, like, constantly, so they do tend to, like, deteriorate over time, and I don't know when exactly I created this one. It might have been, like, 6 months ago, so yeah, it might be pretty trashed. You can actually just, like, look at how many different versions of NVIDIA drivers I have on the desktop, right? That should give you some idea. I have, like, Fermi drivers, Kepler drivers, Maxwell drivers. Yeah, so that literally didn't do anything to the score. So that's the whole reason. Like, I don't see why you would really, like, even, I'm just gonna show you what happens even if we set the AC/DC load lines to 90. Like, it's really just not gonna make much of a difference, right? And 90 is like the setting that the board uses when you're on the Intel default settings. 90 and 90. And we're going to set this to auto. Which, funnily enough, like, yeah, 0.9 is technically, like, below the VRM load line on this board. Because the VRM, as far as I know, is actually set to 1.1 milliohms, but the CEP does have some tolerance on it. So, like, there is, like, you can technically go slightly below the actual VRM load line before CEP gets upset. And a lot of motherboards will actually have when using Intel default settings, will actually have the load line set to 1.1. And yeah, like I still don't see a reason to like go and like, yeah, well, I guess we'll see, but I really don't think this is going to make a big performance change um, right now. So, like, it does technically increase the like peak voltage that you get with the CPU when you have like the higher AC load lines. But you can just, limit the peak voltage by setting a VR voltage limit. So I really don't see that as too much of a concern. Um, oh, and we're back to Cinebench not wanting to start. Oh, there we go. Actually, it might be that I'm like clicking on it too much and it's like trying to start multiple instances, and that's why it takes so long. Actually, because this setup right now is like like the AC load line is slightly below where it's supposed to be, this might score better. Oh no, it scores slightly worse. Um, yeah, so that could be like a little bit of CEP, or it might just be that like the load line is so high now that like you do have that like the V droop compensation kicking in, so that might be like lowering the score. It might also just be run to run variance, like 300 points on a like that score is 39,000 points, and it was 300 points lower. It's like a 1% performance change. So maybe I just like ran it too quickly, or um, that's not like I wouldn't like if we ran it a bunch. Maybe that there was some significant effect there, but yeah, that wasn't really a huge difference. Um, so I really don't see the point in like trying to mash the load line as low as possible. I think pulling it down to maybe around 0.5, 0.55 probably should generally work well on most boards. The issue is like I don't remember off the top of my head what the like I you basically have to test what the load line slopes are on every single motherboard because it's not like accessible from the voltage regulator. I would suspect that most boards are programmed to 1.1 milliohms on the VRM from the factory. Because that is the like because in Intel's own documentation, that's like the maximum load line for the high core count CPUs. And so I would like most motherboard manufacturers are well, not particularly. Actually, I think even Asus has it that like level 3 is 1.1 milliohms, and then level 1 is like 1.7 milliohms. So, and that's actually more effort than what like most other vendors will do. As far as I know, like I think Gigabyte, like the Renaissance boards, I think are all 1.1 milliohms. The on semiconductor, those might be 0.9, which might be why Gigabyte is setting all of their boards to 0.9, because it's not like having some of your boards slightly too low is better than having some of your boards slightly too high. Okay, that's definitely worse. You don't want boards being too high. You being too low, that's probably fine. Being too high, that is definitely a problem. Um, but yeah, so that's like I will be testing a on semiconductor Gigabyte board as well, because I do still have a Z790 Aorus Elite, which has the on semiconductor controller. Um, it unfortunately doesn't have a internal like CP like DyeSense core voltage sensor. So I might have to like hook up the multimeter to it or something. Not the oscilloscope, because the oscilloscope like you like hooking up the oscilloscope to the DyeSense circuitry is generally not good. I'll just put it that way. Actually, even hooking up the multimeter to the DyeSense circuitry is not ideal. But yeah, well, um, I've done that before, and it's less concerning than what happens when you hook up the oscilloscope to it. Um, Because yeah, like you put like the main issue with the way I use the oscilloscope is I do use like a 50 ohm terminated coax. You put that across the DyeSense circuit, and it is not good. Like you cannot put a 50 ohm termination across that circuit. It really doesn't like it. Um, so Anyway, but yeah, so like, you know, if we want more performance at this point, we can just set a lower negative internal offset. And alternatively, we can also go to selection, and then you get this, right? Where you can set the voltage like offset for every single frequency point. So you can like not, because one of like, yeah, so you can just adjust all of your, like if your 6 gigahertz voltage is super high, right? You can just lower your 6 gigahertz voltage. If your like 5.1 gigahertz voltage is really high, you can just lower that one. Um, so yeah, like you can adjust this with a really fine level of control. And as long as you do it for gigabyte boards, as long as you're doing your voltage offsets in the adaptive vCore mode, you're not going to have any problems. If you're on fixed vCore, this won't work. Because fixed vCore basically tells the voltage regulator to ignore the CPU's requests and just run whatever voltage you set at the voltage regulator. So this will not work if you're using Intel default settings or have CEP turned on. Override vCore, I think might be fine because that uses the internal CPU vCore offset. Yeah, so that might work okay. I'm not sure why you would use that though. Instead of just using the adaptive mode, because like it just like it's ultimately the same setting. And then on auto, like this is VRM offset again. Like this isn't vid offset, this is VRM offset. So you can't use that because it'll make CEP upset. So there, hopefully that makes sense. If you have a gigabyte motherboard, you don't need to turn off CEP just to be able to undervolt. You can totally leave CEP turned on. And if you have a motherboard that uses the Renaissance controller, high LLC with AC/DC set to 55 is probably ideal. And then you can also set a VR voltage limit of like 1400. Like, well, if you don't trust Intel's 1.55 volt limit, you can set a lower limit using the VR voltage limit. So yeah, hopefully this addresses the whole like CEP ruining performance thing for gigabyte boards, because obviously like I don't know how to act, like off the top of my head, I don't know how to access the vid offset on an MSI motherboard. It might be labeled differently. Actually, I can basically guarantee that it's labeled differently. So yeah, I will be doing something for MSI boards because I do have a I still have the. Do I still? I think I still have the Z690 DDR4 board, and I have a Z790 Godlike. I also have a Z690 Unify X, so I might do some of those. Um, and I'm not like I'll probably only do one of those. I don't want to have to go through every single board. I have some Asus Apex boards. I'll do those. I don't think I have any other Asus. No, I do have a Z690 Formula. But that's basically the same VRM as the... Oh, okay, I should not say basically the same VRM as the Apex. The Apex VRM is way nicer. But the controller, off the top of my head, is the same. So the way the load line stuff works is going to be basically the same, I think. But yeah, so I'll do a video for an Asus board. I think MSI boards actually don't give you the ability to set a VR voltage limit, which is not ideal. But again, if you set a minus, like, you know, if we go back, like the like adaptive vCore mode, this selection mode, like this is standard from Intel as far as I know. Now, as far as I know, it was also buggy on some BIOS versions, like this wouldn't properly work. But like MSI boards should have this. So if you're concerned about your like high frequency max vid, like you could just, you know, put a lot of effort into turning that as low, like tuning that down as much as possible. And that would that should significantly reduce your maximum vid voltages. So actually, well, not really, because your highest, like the biggest spikes you usually get is like load transitions, which would probably be tied to something like the 5.8 or the 5.6 ratio. But yeah, so like it would be nice. Like we'll see. Like I'll do I'll look at what's available on MSI boards, and if the VR voltage limit isn't available, well, I guess don't run i9s on MSI boards. Because you'll have no way to lock the max voltage below what Intel locks it to. So, I mean, I still don't think that like I'd like to believe that Intel's internal reliability test data is like good enough that the new 1.55 volt limit is correct and it's a low enough limit, cuz like it would be kind of like I would like my suspicion is that the whole reason that we have this whole controversy going on is that Intel just internally never really, like somebody measured the maximum voltages that the silicon can tolerate. Somebody implemented the power delivery spec, and these two people never talked to each other. And then somebody else implemented the boost algorithm. Um, and none of these people ever like talk to each other. And so you ended up with a boost algorithm that will just, due to how the power delivery spec works, will sometimes send vid requests for 1.6 volts. And nobody bought, like, and they just never checked, which is still a massive fail, but that would be much less of a fail than, yeah, the guy doing the reliability testing came to the conclusion that 1.6 volts is a good idea, right? Or like the team doing the reliability testing came to the conclusion that 1.6 volts is a good idea. That would be way worse because that means even that would put into question even the 1.55 volt limit because it's like, well, they were wrong once. Why can't they be wrong again? Whereas the whole, like, if they just didn't talk to each other about how things work, that would be less bad. Instead of like, oh, actually, they're just working from completely incorrect reliability data. Anyway, this video is now getting off topic, so yeah. But again, the one takeaway I want you to have from this video is that you don't need to turn off CEP to undervolt. If you're undervolting and CEP is ruining your performance, you're not undervolting correctly, basically. Like, whatever you're doing it wrong. Okay, you should stop doing that and you should look for a different way to offset the voltage. Because as far as I know, every LGA 1700 motherboard, if it has a if it has voltage offsets available, it should allow you to adjust the vid offset, and that won't trigger CEP. And so you should just use that instead of whatever it is that you're using that is triggering CEP. So, yeah. Anyway, that's it for the video. I'm going to go swap motherboards now. So, yeah, thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. So yeah, it would be much appreciated if you check that out. There's also the Teespring store where you can pick up shirts, hoodies, posters, the usual YouTuber merch. And I've also got a Bandcamp. There's links to all of that down in the description. And that's it for the video, so thanks for watching, and goodbye.